Hello everyone, my name is Rajesh Kumar and I'm your DevOps SRE DevSecOps coach. I have close to 18 plus years of experience working in multiple MNCs around the globe and having in-depth knowledge of DevOps, SRE and DevSecOps. So I would like to introduce you one certification program in a DevOps, and that is we call it DevOps Certified Professional. Now this is a 2 months of program, 25 tools of DevOps you will learn, and apart from that you will also get the access to the LMS, lifetime access to the videos portal. It's a certification program, and you will have 25 assignments and 2 projects along with it. It's a completely weekend program, so here you have classes on Saturday and Sunday. So as part of this course, you will learn multiple things. Here you see that you will learn Linux, AWS, Docker, Jira, Confluence, Python, Git with GitHub, SonarQube, Maven, Gradle, Packer, Artifactory, Selenium, JMeter, Ansible, Kubernetes, Helm, Terraform, Jenkins, Datadog, Splunk, and Neuralink. Now, how do we, apply for this? So how can you reach out to us? So you have a WhatsApp number and email ID. So please reach out to us and we'll help you to onboard this program. Apart from this DevOps certified professional programs, we are offering other certifications as well in a DevSecOps, SRE, and one of the very comprehensive programs which we have is in Master in DevOps Engineering. Yeah, so feel free to get in touch with us and then enroll for it. Thank you. Okay, so what we are going to do is understanding first thing what is Helm. Okay, that's the first thing. Second thing is why we need Helm. Third thing, how Helm works. That is what, why, how, and then followed by we'll have some a demo and lab. So demo for the installing the Helm, using the Helm and stuff like that. So what is Helm? So before that, in order to learn Helm, we need to have a understanding on Kubernetes and of course some Linux commands, and that we have it already. So
Uh, just a second, Rajesh. I'm able to log in now.
yeah,
That
yeah, that's
then
good.
then
I'll tell
what
you.
is the
I'll tell
next
you.
is yeah,
I'll
okay.
tell you. Yeah. So what is Helm? So Helm is a package manager for Kubernetes. Simple package manager for Kubernetes. Now I'm assuming all of you are very comfortable working with Linux machines. Correct now? Let's say Ubuntu or CentOS or RHEL. Correct, all of you? Hello? Hello?
Yeah,
Yes,
fine. It's
Rajesh.
Yeah,
fine for us.
yeah. Let's make this session interactive. So my question to all of you is, if you want to install some application in Ubuntu, let's say, or CentOS, how do you do that? Any idea?
Apt-get install.
Using apt command.
Yeah, you know that. So you use apt and apt install git, apt remove git. Simple. Yum install git, yum remove git. Agree with me, right? All of you?
Yes, Rajesh.
So
Yes.
in apt, if you go further a little bit detail, what kind of package you have? So you have a Debian package. Yum, what kind of package you have? You have RPM package. I don't know how many of you from the .NET background, if you have used the NuGet or Chocolatey. So what package they have? MSA file, exe file in Windows, correct now? Windows
Yes.
file, yeah. So you
Yes.
you install that application and remove the application. That you have done it hell lot of times. In Windows also, if you manually, command line, if you want to do, you can use a Windows NuGet or Chocolatey, or maybe most of the time what we do, install that through clicking on the exes and then uninstall through the add and remove program. That is how you do that. So that is a system side. Okay. Now in a development, I think some of you are from a development background. So how do you manage the package in Java world? So Maven, we use it. You know that if you have knowledge on this, or maybe if you're a JavaScript guys, npm you must be knowing actually. This is how you install the different packages, install or uninstall. Python packages, we have a pip. So I think more or less we understand this system package manager and development package manager, correct now?
Yes.
Yeah. So now the question is, how do we install packages on the Kubernetes? Okay, why do we need it? That's a different question. How do we do that? So there is a client, package manager client. It's a tool. It's just executable. Put it in a very simple way. It's just executable. This is called Helm. And Helm is a way to install the package. We call it charts. What is charts? How to create a chart, how to use the chart. This all we'll discuss in some time. But charts. Simple. So in simple way, Kubernetes Helm is a package manager for the Kubernetes. And installing what? Installing charts. Similar way, what you install using apt devin package, yum rpm package, maven jar, ear, or whatever it is. Are you understanding, all of you?
Yes.
Yes, Rajesh.
Yeah. So yes, nothing great. In Helm, if you want to install, look at this system, apt install MySQL. And if you want to update it, the package apt update. Something similar we have on Helm. Helm install the package name, that release name. This is a release name, MySQL, the name of the installations you can say, and this is the package. This package is coming. This week in here we call it charts. Remember, so this charts coming from the internet, some registry which I'll show you. Now you want to upgrade it. Helm upgrade MySQL and this one. So here you can correlate this one. It'll be easy for you to understand. So now in a nutshell, Helm will do install, upgrade, uninstall in a simple way. Yeah, many other stuff also there which we need to learn and get going. Okay, so Helm is a tool, is executable, is a executable that streamlines installing and managing Kubernetes application. Think of it like apt, yum, homebrews for Mac for Kubernetes. So look at this. This is a very simple image. There's a chart repository. Okay, chart repository here is a local. So when you run a command Helm, some commands I'll teach you. Install, here you have seen install and upgrade. So it will take the chart from the local repository and then install in the Kubernetes. Simple, nothing great. So my questions to all of you is like, did you deploy any packages, YAML file in Kubernetes? Let's say deploy.yaml file or service.yaml file or pod.yaml file. Have you done it, all of you?
No.
All of you? No?
No.
Pod.yaml file, deployment, PVC, PV, secrets. Let me ask you one question. Okay, little bit off the track I'm going. I want you to have a maximum benefit from this session. So this is the Kubernetes cluster. Okay. Now you want to deploy one applications. So tell me at a simple level, not very complicating these applications, what are the things you'll deploy to up and running in Kubernetes? All of you?
All the services.
Okay. So first we'll
Major
deploy,
pod.
correct now? Second, services. Third, stateful sets. Fourth, config map, maybe secrets, service account, PV, PVC, namespace. What else? RBAC related permissions. You know, so in order to run this one application, you need to deploy all this YAML file. So what do you do in order to deploy YAML file? Qctl apply -f YAML file. Correct now? Qctl you might have used it right now.
Right.
Yeah.
Correct.
So these all are YAML files. Okay. Now you say, Rajesh, I have not used the YAML file, maybe command. Yeah, but that is short term, temporary. Most of us, because see, I'll tell you, you write one command and give you 50 parameter 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or I'll give you one file which has a 50 parameter, which is easy. Tell me. There is one file, YAML file, which has a 50 parameter mentioned and just run to apply only one. Or I'll give you one command with a 50 parameter is like a very long. Which one you find very easy to deploy?
YAML file.
One with the file.
YAML file, simple. So we deploy through YAML file. Maybe you have learned through commands also. That's okay. Okay. So we deploy using YAML file. In order to run, okay, I'll put it in a more simple way. Are you aware of AWS or Azure? All of you?
Yeah.
Yes.
Yeah.
Yes.
So nothing great. What do you do in order to run your one applications? I'll tell you. Please correlate. Okay. You run your application in an EC2 instance. After that, let me write it. It will be easy for you to understand. Okay. So here you run application in EC2. After that, you have auto scaling group setup. Correct. After that, load balancer also setup is there. First, these are the compute and scaling. Then you go and EBS attached to that. You are using S3 also. You are using EFS also. That is a storage. Then VPC networking you go and set up. And then what you do? Route table you do. Route 53 for DNS operations. What else you do? CloudWatch you enable for this monitoring. Correct now. After that, what you do? You have some managed services like what? SES, SNS, SQS, all this thing. Correct now. So in order to run one applications, you need at least minimum these services. Correct now? All of you? Hello?
Yeah, right.
Yeah.
Partially. Most of
So,
them.
so this is you are on AWS. Let's go into the Kubernetes. What do you need? Pod, deployment, a stateful set. I'm just writing in, so please ignore the spelling mistake. Auto scaling group, you have in deployment. Load balancer, you have service. Okay, EBS, PV, PVC, you have it. Config map, you have it. Security manager and all. Secret manager, you have here also, right? Secret manager. So config map. I'm just correlating, not net to net, but like this. Storage class here you have. VPC, you have networking, Calico and all you install. Route 53 DNS service. CloudWatch, you have met some monitoring tool, let's say Prometheus, and some managed services. So yeah, what you are doing now, earlier what you were doing on AWS, everything in order to run applications. So now what you do in Kubernetes, you deploy all this YAML file. In order to run one applications, you have YAML files and you deploy. Make sense, all of you? Hello?
Yes, Rajesh. Yes.
Yeah.
Yes, Rajesh.
So what is the Helm? So guys, think of frustration first of all. Think of frustration. In order to deploy, think of it. In order to deploy one applications, you have a 50 YAML file. Mind it, 50 YAML file. So you need to do 50 times apply. You want to upgrade after 1 hour or after 2 hours. 50 times you have to run the command upgrade. Think of it. And 50 times you have to do remove, install, uninstall, delete, whatever it is. So how many times you have run commands? Just think of it. You run 50 is to then 50 plus 50 plus 50. So in order to apply one application on real time in the production, if you follow this approach, kubectl apply xy YAML, kubectl apply xy YAML, then 150 times you have to do. I'm trying to help you to understand the frustration. Do you like this? 150 times you need to run commands?
No.
Of course not. So if you don't like it, then use the helm. Simple. If you feel frustration, helm, one command for, I just showed you the command already. One for install, one for upgrade, one for remove. Simple. So if you are asking me why we need Helm, why we are learning Helm, Helm is not a very complicated tool. It's a very simple tool, which will help you to, which is developed for saving your time. Actually, that's all. Where you can install the whole hell lot of applications, YAML file basically, in one go, upgrade in one go, and remove also in one go. Making sense, right? All of you.
Mhm.
So you see that image, Helm directly deploy the chart. Chart is your package. You call it package or you call it chart, both are okay. Now, what is a chart? I need to discuss with you. You have understood by now. Charts is nothing but it has all 50 YAML files in a certain structure that I need to teach you. Okay, so Helm is the best way to find means see, I think you are developing one product. You are developing one product. The product name is DevOps X. So think about it. I'll put it in a more contextual way. Okay, this product you have developed, and tell me one thing. Will you give one installer or you will give 5,000 files? This software you have written in Linux or Windows, maybe Java code or Python code or whatever code, which one you would like to uh, give it, share with the people? One installer, or 5K files. Both are okay. Both will be can be used to run the applications. Which is easy? Tell me.
One installer.
Of course, you know that nothing great about it. So same way, now you have written the same product in the Kubernetes YAML file. So you don't want to give 50 files. What do you want to give? One package, okay, which you want to share with the whole world. Those who wants to install it, they will find a package and they'll install it. Very simple, nothing great. So here, Helm is the best way to find package. Where you can find a package. Now the question is where can you find a package? So this concept we call it registry. Okay, so let's understand this concept of this one. Registry concept, then repository concept. This you need to understand. Very simple though, and I know that most of you have understood this one and using on daily basis. Anyone would like to tell me what is a registry and what is a repository? Anyone? Just try also, will work.
In this registry, are you referring to the OCI registry, the norms that we have set, and or some normal registry?
See, registry is a global terminology. It's a terminology. So registry, I'll put it in this way. Registry means a place where you host the repository. Okay, a registry where you host the repository. For example, one example I'm giving you, GitHub. What repository you are hosting? Git repo. I'll give you one more example. Artifactory. Artifactory is a registry. What you installed or what you can host. So you can host Maven repository, Helm repository. Okay. Different time. So this is the source code repository, and this is the binary repository. Nexus, if you have used it, have you heard about the Nexus or Artifactory? At least one tools must be there in your project. Getting more points? So registry is a place where you have a different kind of repository, and repository can have your source code, SRC, or your binary, or Docker image, or file system. Can have source code means Git, binary means Docker image means Docker Hub is a repository, a registry. Docker Hub, you know that, right? All of you.
Yes.
Ubuntu image. So Docker Hub is a registry, and you have a repository over there, and that repository has certain image, Ubuntu image, Python image, Jenkins image, this image, that image. So concept of registry is very simple, correct now? So here you have a registry, and then we have a repository. Repository in this context, repository will have a charts in our context, Helm context. Okay, you will have a charts. So now the question is, where is the registry? So here you see that here, look at this. Helm is the best way to find, share, and use software built for Kubernetes. And the software, the address is helm.sh. Helm.sh is a place where you can find chart, share your chart, and use built for the software built for Kubernetes. Now, can we go to the helm.sh? Helm.sh.
I have one question here, Rajesh.
Yeah.
In the registry and repository,
Mhm.
can you open that where you have mentioned
Yeah.
GitHub
Yeah.
and everything? Yeah.
Yeah. Yeah.
So you are saying registry is where we host our repository. So GitHub is a registry and we are hosting different repositories on that, right?
Correct.
But in GitHub, in our repositories, we can see there are separate places for container registries and all those. So is it so that we are hosting another registry inside a registry, or it's a link to a registry? What exactly that is then?
No, 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 no. Now, on a GitHub, you have a Git repo, and Git
Hmm.
repo, you have a source code, okay,
Yes.
which you store. But GitHub now is offering also artifacts repository also. Okay, so
Hmm.
that is separate. That is artifact means the packages like a Docker packages, like a Docker hub. So GitHub is acting like a like a Docker hub also. Okay, so in a GitHub, you have
Mhm.
source code, and there's one concept of LFS, large file system. So you can
Yes.
store different packages also. So packages also is a repository.
No, so though
Registry will,
that tab container registry that comes, that is also you are saying is a repository only. It's just named as registry.
yeah, maybe like that. Registry means is a place where you host the multiple repo. Repository is a place where you host the package or Docker image. So here you are saying container registry. So
Yes.
container registry is basically a registry is like a registry, and at the container registry you will have some image
Yes.
name like
Yes.
devops x
Yeah, we
y
store,
whatever
you can say that for that particular source code, when it
yeah
get builds, the images of that
image yeah
source code are
yeah
stored in the container registry.
ah.
So what this registry is exactly this? Is it a
So
repository or it's a registry?
No, this container registry, as name suggests, it is a registry. Okay,
Hmm.
hosted by GitHub. It's a company name GitHub. Inside that registry, you will find images. One image, two image, something like that. So each account, when you create, you will get one registry named with yours. For example, I'll put it in a contextual way. Let's say go to hub.docker.com. So hub.docker.com is a registry. Okay, this is the
Yes.
registry. Now, if
Yes.
you log into this, okay, log into this, it's like a GitHub only. And here you can create a repository. See, let me show you this. Create a repository. And in this repository, your image will be there. So
Yes.
your repository name is equal to image name.
Okay.
Got it?
Hmm.
Like that. Okay. So now, yeah. So coming back to this registry and repository, you understood that. In our context, repository is is nothing but a charts, and we need to find out the registry. So where is the registry? Helm.sh. By the way, so many registries are there. Bitnami registry is also there, which we use a lot. We will use it. But today, Helm.sh. So go to the Helm.sh. Now this site is closed actually. See here. So Helm.sh, and here you go to charts. And now I just said, right, it's closed. Now all the charts, you can find it here. Artifacts hub. Remember this, artifacts hub. Now you want to understand that how many charts already there. Okay, understand this way. You know Play Store, right? Play Store, all of you use every day. So Play Store is your registry, and you install WhatsApp application is a repository project. Got it? Very simple. So here, find, install, and publish what? Kubernetes package. Package is equal to charts. Okay. Earlier we used to call it charts. Nowadays we are calling package also. Okay. Now how many packages you have? How many charts you have? Look at this. And here you can search for whatever the you want. Let's say search for MySQL. See here. When I search for MySQL, look at the filter, official, verified, CNC, kind, categories. So these are the charts. How many results has come? I think so many results has come. So anyone can publish their own charts here, but you should always trust the official or verified. So here you see this is the verified and MySQL chart. Who's the provider for this? Bitnami. So Bitnami is the hosting place. You see the URL charts.bitnami.com/bitnami. So this place is referring to another registry where this chart is hosted, but it is one place for finding all kind of charts. Are you understanding, all of you? Hello?
Yes, Rajesh.
Yes, Rajesh. Yeah.
Yeah. So this is a tool. Earlier used to be helm.sh. Now where to find out? Artifacts hub. Simple. Location got changed recently. Now you will say Helm is a client, is a executable. Where it has to be installed? Mind it, Helm has to be installed at the same place where kubectl has been installed and configured. I repeat, Helm need to be installed. Helm is a utility client tool, need to be installed in the same place where the uh, what do you say, um, kubectl is installed and configured. Now this tool is written in Golang. Go is a programming language which has been used for writing this tool. So you know that Go is a platform independence. That means you can install Helm client in the Windows also, Linux also, and Mac also. So no problem. Okay. And using this Helm, you can manage the whatever the application installed in the Kubernetes cluster. Now this particular product is maintained by CNCF. Now what is CNCF? Anyone?
Yeah, cloud that foundation where all the stuff related to Kubernetes is maintained.
Yeah.
Uh,
So Kubernetes, CNCF is like a foundation. Foundation. If you want to compare CNCF, you know Apache, right? Apache is foundation. They manage the thousands of open source product. So same way, the Apache is managing the old generation of software. Cloud CNCF is managing the latest generation of software, more or less related to the container world, actually, cloud and container world. So Kubernetes, Prometheus, Linkerd, Fluentd, Helm, all these are managed by CNCF. They have a more than 50 product actually. So you should check that cncf.io and you get comfortable, because that's the technology we'll be using from now onwards. I mean, we have already started using it, just like Kubernetes. You learned, then now you're learning Helm. So like that. Okay, now it is maintained and in a collaboration with Microsoft, Google, Bitnami, and some contributor as well from the community. So that is a help. So yes, I think more or less you understood this. We install the old chart, then we upgrade with the old chart. And if you see that Helm is the same place where you have a kubectl. So if you understand the how kubectl works, same way Helm also work. So Helm will read the configurations of kubectl and for authentication of API server of cluster. In Kubernetes cluster, you know that you have a master server, right? And the master server, you have API server. So kubectl talk to API server and use certain authentication certificates and all. Helm uses the kubectl configuration itself to talk to API server and deploy similar to what kubectl you've been deploying. The only thing is it save your time in order to deploy the charts. Okay, so using that Helm now, you can deploy the packages in a different namespaces also. Okay, so default namespaces and other namespaces. So what are the features of Helm you have? So first of all, it has a charts. It manages the charts and templates. Now, what is a templates? I need to talk about it, but at a high level here, templates is nothing but your YAML file, the same YAML file which I discussed, deployment.yaml, service.yaml, config.yaml, uh, secret.yaml, all these things. Now here, Helm also help you to manage the dependencies. What dependencies? For example, chart dependency. Chart dependency means, hey, in order to install the my application, before installing my applications, some other charts should be deployed. For example, let's say Tomcat should be deployed, or some PV should be deployed, some PVC should be deployed, something like that. So here you can make a chart dependent also each other. One chart will deploy only after the other chart, something like that. You can do that. So because you may have a multiple chart for your applications, in that case, it manages the dependencies also. And repository. So
Rajesh, one question I'm having.
yeah.
Uh, what is charts meaning over here? Means we are seeing that your helps manages charts, but like from the conceptual point of view, what is exactly a chart? Like as we understand, chart is something graph or table or those kind of interpretation we are having. So what exactly the charts meaning over here?
Yeah, this is a little odd actually. I don't know why they call it charts, but I'll put it in a very simple way. Charts basically you can call it now package,
All
but
right.
then you'll ask me, Rajesh, what is package? Is it a exe file? Is it a tarball? Is it a zip file? No. Answer is no. Chart here, a package here or chart here is a directory structure. Mind it.
Mhm.
Directory structure of YAMLs. That's all. In a simple way I'm putting up. I'll complicate a little bit later. Now we'll say which YAML. So I think you know that what YAMLs I'm talking about.
Mhm. Yeah.
So chart is equal to package or is equal to the directory structure of YAML. Got it?
Yeah. All right. Thanks.
Yeah. So I'll teach you this directory structure. So now, and also these charts you can feed in a repository, which I'm discussing also. Okay, so some of the hell advantages. one of this thing is manage complexity. I told you, right? In order to deploy your app, you have to deploy a hell lot of things, and that is solved by Helm. You want to update, one command to update. You want to roll back, one command to roll back. Okay. And sharing, that means whatever you deploy, you can share with your team or your client easy way. So that is the advantages which we have for Helm. Okay, so same thing which we have. These are the sponsors for this particular tool. So now this is the timeline. Okay. More or less, I want to tell you two things. One is Helm 2 and another one is Helm 3. That's all. Rest of the things is not important. So right now, today, I'll teach you Helm 3, which is from last few years. Okay. But also, if you Google it, lots of content, you'll get it from the Helm 2. So Helm 2 and Helm 3, architecture wise, lots of differences are there. So I'm not going to talk about the Helm 2 because anyways, we never use it, Helm 2. But remember that when you refer the documents, keep in mind whether it's referring to Helm 2 or Helm 3, because in a tutorial in Google, you'll find lots of materials for that. So right now I'm teaching you Helm 3, okay? And that is the started that development in 2018 plus. And after that few years, we had this tools ready. So remember that the version which we are using is Helm 3. So look at this. I'll show you the many images for this to understand how it works. Okay. So here you are the developer. Okay. And in your laptop, Helm client is installed. Okay. And you say, hey, I want to install some chart. So chart will come from some repository. So local repository concept and remote repository. So here actually, let me tell you, this is the remote repository. So what happens at a high level? This is your laptop and this is you. Okay. And you are using this laptop. Here Helm is also installed and kubectl is also installed. Kubectl is configured with kubeconfig. Okay, so Helm is using same authentications. So now this is your repository, registry, sorry, and this is your cluster. So what happens? Think very simple way. It's not difficult. You have a charts available here. So first you chart download to the local. I'll teach you the command for that. And this charts once you have in local, then you deploy this chart in the cluster. Simple, that's all. And whatever the chart, I said multiple times, chart is having YAML files. So whatever the kind of YAML files you have, you got deploy pod, this, that, and all kind of thing. That's all. Are you understanding, all of you?
Yes, Adesh.
You'll say, Rajesh, I want to write my own chart because I have my application, I want to install it. Create your own chart, publish it here, and other people will take it same way and do that stuff. Find, share, use. Very simple way.
Rajesh, just one thing I want to ask. Let's say I have one service only that you showed for MySQL and everything. So
Mhm.
just for one service, why do I need chart? Isn't the Docker file just starting a Docker file, starting MySQL through a Docker file is enough?
Yeah, I understand your question actually. You are thinking when I say MySQL, that means just deploying MySQL image. You are thinking
Yes.
like that. But in reality, when we deploy in the production server, we deploy MySQL, we deploy PV, we deploy PVC, we deploy SA, we deploy some config map, we deploy some secrets. In reality, like this.
No, I get your point that in my production, let's say in my production, my project needs some specific things. So I'll create my chart YAML and configure all these things and then use this Helm to deploy it. But the repository where you showed the charts repository that
Mhm.
have right, so what does it contain? My question basically is, what does this particular chart contains? Because it's just MySQL starting MySQL. It's something open source. No specific project requirements. It seems to me like just starting my MySQL image.
Yeah, that's what I said. Seems like MySQL image, but other resources also there as part of this chart. So that multiple YAMLs, production ready YAMLs are there. Using this chart, you can deploy. Now,
Can we see what's in this chart? This MySQL chart means any one chart example. Can we see from
no,
this open source?
yeah, we'll get into that discussion. But again, I have answered this question. Chart will include what? YAML files. The same YAML files you are also talking about. You are telling me, no, Rajesh, what is the big deal? Just create one YAML file for deployment and deploy that. Correct, no?
Mm-hmm.
But I'm saying production ready deployments, you'll have a multiple YAMLs, and that YAML file is in your chart. I can show you that, that's not a problem. But understand that it's just a YAML file. In a put it in a, then you'll say, Rajesh, why we are using YAML file? I mean, why we are using chart then? Helm then? Why can't we deploy? I give you some of the reasons. One of the reasons is this one. You want to deploy multiple YAML or one command? One thing, that is a one reason. Second thing, you want to share with your team, your client. Are you going to send 50 files or one files? Third reason, can we have it one centralized place where all this publicly YAML file easy to install, easy to do that? And dependencies. One package is dependent on other package. So can we have that also mapping out? So these are the some of the reasons using that we are using YAML. I mean Helm. Make sense?
Rajesh, one question I'm having. So, you said like the Helm is a directory of a structure, or the charts are a directory of
Let
YAML
let
file.
me let me do one thing. Let me do one thing. Just a second, because these questions will be rising. I want to give the piece to this question. Quick demo first before discussion. Okay.
Yeah.
Helm. See this. I created one chart quickly. I'll teach you a little bit in detail later. What is Helm? This is a chart I created in front of you. What is this? YAML file. What is this? YAML file. This is your service. This is a deployment. It's a blank one right now, but that's all. This is your chart. You see that? Got it? It's a directory structure. It's your chart, one chart. Got it? Hello? Mm, am I lost you?
Yes.
Can you please open that folder once again that is created?
It's it's a deployment file.
All right.
You'll not.
Uh,
It's a deployment file. Thinking you'll not understand this file, but let me show you one simple file.
uh,
Oh, just a second. Hold
yeah.
on. Wait a second. Just a second. Pod dot. For example, deployment jump. This you might have done hundreds of times. This is a pod. You see, kind is equal to pod. This is your YAML file. This is kind is equal to deployment. This is your YAML file. This is the file which I'm showing you here. So you know, no need to complicate your understanding right now. It's YAML file for service, YAML file for ingress, HPA, deployment, pod, service account. This is a I mean structure. Got it?
Yeah, miss, I got the point, what you're saying, but yeah, my question was actually different. So, what I want to ask is like, let's say we already have a production system in place, and
Mhm.
we already have these Kubernetes files or the YAML files, which we already configured based on our need, like what kind of resources or what the things we wanted. So,
Mhm.
if we want to migrate that to a Helm, so is the structuring of those YAML files is
Yeah.
sufficient enough, or
Yes, that's all. That's all. Don't complicate yourself.
mhm,
Don't complicate yourself. Put it all the YAML files in this directory and install it and
mhm,
uninstall it. That's all. No need to
all
complicate it.
all right, okay,
Got it? It's
yeah,
very, very
thanks,
simple though.
okay.
Any confusion?
Uh,
I'll
no,
teach you that how to
yeah,
create.
yeah, probably by the session goes off, yeah, probably then I'll ask.
So guys, look at this here image. Chart is coming from the repository. It can be local or remote and installing in the Kubernetes cluster. Look at this here again, chart repository using Helm client. You are deploying in the Kubernetes cluster. Look at this one, little bit elaborated. Multiple chart files are there. Helm. So from where they are taking the chart file, look at it very, very carefully. Going to the repository stored chart, the artifact have just now I showed you. Okay, so they're taking the files from there, putting in the local here and deploying the cluster. See, create, install, upgrade, rollback, delete, status, versioning, what? This chart. And this chart is nothing but a file system which I showed you. Got it, all of you? So what is the workflow overall? So first you create a chart. How to create chart, I'll teach you. Actually, I created a skeleton of chart just now using that command. Then you upload the chart as a dev team to the repository where artifacts hub is one place. Artifactory you must be using or Nexus there also. Are you aware of Artifactory or Nexus, right? All of you?
Yes.
JFrog Artifactory or Nexus.
Yes.
So,
Yes.
so there you will upload that chart, and then people who wants to deploy that chart, they will get it from there, download it from there, and then install in the Kubernetes. This is the complete workflow. Okay, so yeah, few more images if you want to deep dive. Repository, you have multiple charts. Download number charts at template. Just now I showed you template means look at this directory. Inside that you have all the YAML files. I'll deep dive into that one by one, not complicating. And here you have deploying in the Kubernetes cluster. Kubernetes cluster, your master node, worker node. This is a little bit elaborated image, which you understand. So I'm assuming you are very comfortable with Kubernetes. Okay, same image, put it in a longer way. Look at this. Chart is being downloaded to the local machines and using the command installing to the Kubernetes. Are you comfortable? Hello?
Rajesh, just one question.
Yeah.
Just I mean, to resolve my confusion. Let's suppose I need to install MySQL, right?
Mhm.
So I'll get a chart for MySQL chart. For that, if the dependencies are, let's suppose we need an EC2 instance first to be established, or we need
Ah, wrong
something else
question.
also.
Wrong question.
Mhm.
In order to deploy a chart, you don't need a EC2 because that cluster, Kubernetes cluster is already running no on EC2 only. So you don't need a EC2.
Okay, okay. Forget about EC2. Any other
Yeah.
service. Let's suppose I need to
PV.
install MySQL,
Hmm.
right? Oh,
And you
okay,
need a
let's say
PV.
PV.
Huh.
Yeah. So that PV would be under template. That YAML for PV would be under template, and uh, MySQL as a chart would be some other YAML file, which will install MySQL over that PV, right? Is it like that?
Can be said something like that. See, it's up to your approach. For example,
Means
I'll tell
I'm a
you.
bit confused between the files under the template folder and what we are going to install mainly. Because you have showed the example of MySQL, so I'm taking that only. But what
Yeah.
comes under the template, I'm getting confused.
See, in order to deploy your MySQL, let's say, so deployment.yaml, correct? And then pv.yaml and
Mhm.
pvc.yaml. This you will have it. I'm just giving you example, and one maybe service account.yaml. So this you will have a YAML file. What you will do typically kubectl apply, kubectl apply, kubectl apply, kubectl apply, and your MySQL is running. This is a traditional way. Correct now?
Mhm. Yeah.
Now what you are saying, hey, it's very odd way to deploy. Multiple commands are there, and it's very not easy to share with other people also. So what you do, you you go ahead and create a chart. Put this file inside the templates directory. Simple way I'm telling you. And now your chart is ready. That's all. So now what we need to do is Helm install MySQL. That's all. Helm upgrade MySQL. Helm uninstall MySQL. This you have to do. Now you say, oh, that is running. MySQL is running. Everything is working fine. So this zip this one, this directory, zip or tar, and upload to one place where everyone can access. In our case, we have this one. And other people will take it from here and they will do the same thing. Very simple flow. That's what I'm trying to tell you.
Okay. So here, PV YAML, PVC.yaml, SA.yaml are dependencies, right?
This is the internal dependency.
Internal dependency, right? So
Ah, now,
deployment.yaml would have a configuration of MySQL, or it is also a dependency file.
okay, so why we are having this question, I feel because
Or what? Uh-huh.
we have a limited exposure to Kubernetes, I feel. Because
Mhm.
deployment.yaml will have a MySQL pod deployment, no?
MySQL.
Yeah.
Yeah, it
So
should
that
have, right?
and this pod we may configure with PVC. This is for security. I mean access.
Okay.
So like that.
So what will come under the chart folder? That is also another folder, right?
So under the chart, there's one file you'll get it. I'll explain it to you a little bit later.
Okay. Okay, fine.
Here this file is there. So I'll talk about this file in some time, 2-3 minutes. Got it?
Okay. So there's chart.yaml and there's chart folder. Both are different, right?
I'll talk about it.
Okay.
Okay, so now at a high level, you guys are understanding. It's not a very difficult things. It's just a utility for deploying the applications, the package chart in a Kubernetes cluster. I will teach you how to deploy, how to upgrade, how to uninstall,
Ashad,
and
Ashad,
how to create
internet
it.
नहीं आ रहा.
Yeah, I think your voice is audible to all of us, I guess.
Oh, I'm
In,
really sorry.
yeah. So getting my points, all of you, right? Hello? Hello?
Yes, Rajesh.
Yes.
Yeah.
Yes.
Okay,
Yes,
so
Rajesh.
now you will say, Rajesh, what it contains in the template folder. Okay. And here, let me show you this. Okay. And let me just a second. Here, values.yaml. You see that here, this file first, values.yaml file. Okay. So just a second, I'll tell you. Command in Windows with files list. Uh, I think this one. Okay, so now this will be clear. This is clear, right? So now you will ask me, Rajesh, okay, fine. Chart you have, you understand that Helm very well. And then what it contains. So here, if you see that, oh, wait a second. Correct. So here, if you see the templates, so what it contains, just now I explained it to you. And then you'll ask, what is this? And then you'll ask, what is this chart.yaml? Ignore that file. Ignore file is not needed. Correct now? All of you? So what it contains, template file, already I have explained it to you in easy way. Little bit more explanation needed, but you understand that. Correct now? All of you?
Yeah, Rajesh.
Yeah. Now, question is what it contains in value.yaml. That is a question now. So understand that. I'll put it in a very simple way. Let's say in MySQL, pods you want to run 2 or 10 or 20. Should you hard code it in the deployment.yaml? Or we should parameterize and keep it in some configuration file? Which approach is good? Because see, same Helm chart, MySQL Helm chart, you are using, you may need a 10 pod. I needed 200 pod. Different team, different project, different requirement. So you want to put all these kind of values. Let's say I'm talking about only pod, number of pod, but let's say you need MySQL 5. I need MySQL 6. Image will change, correct now? Docker image. Hello. So
Yeah,
my
Rajesh.
questions to all of you, what do you prefer? You want to hard code in the Helm chart and people will struggle all this file, long file and change this hard coding, or you want to keep it in a separate parameter file? You suggest me. You suggest me. Hello?
Parameterized file.
Parameterized file. So if you have this understanding, then you should not be struggling for values.yaml. What values.yaml will contain? So values.yaml will contain all the variables which should not be hard coded in the deployment. I mean, in the all this YAML file. That means before deploying, please hear me out. Before deploying, if you want to change the certain values, you should modify this file. Let me show you. Values.yaml. See here. So here you are saying image dot repository should be nginx. That means nginx image will be deployed. How many replicas count? 1. So here I say no, I want to deploy nginx 6 or 3 or 4. So you can like modify. Right now, how many replicas? 1. Which image? This image. You want to change this, all this thing. All this service account should be created, not created. Pod annotations, some you want to annotate it. Security context. Service should be clustered up. What are the types of service? Anyone would like to tell me? What are the types of service? Hello, guys. Hello.
You are
I'm
audible,
out.
Rajesh.
So guys, cheating is allowed. Okay. So if I ask you any questions, maybe you don't know. Here, types of Kubernetes service. At least you will have some learnings instead of nothing. So immediately do that. And here I got to know within a few seconds. Okay, there are 4 types of it: clustered IP, node port, load balancer, external name. At least you got to know These are the types of service. These are not the one directly used, but these are the 4 types. Okay, so now which one is mentioned here? Which type of service you want? Load balancer. So here I open this file, cluster IP. So here cluster IP, but here it can be node put also, load balancer also, external name also. So anything you want to pass to this deployment, ingress is there, false true. Certificate should be there, false true. How much CPU RAM for this pod? Auto scaling, how much? See here, minimum replicas to HPA, you know that, right? HPA. So here this setting you have it. This settings you have it. So now you understood this, what it contains, correct? At least values.yaml, what it contains. All of you. Hello.
Yes,
Yeah.
yeah, it contains the
So
parameters where we can use
parameters,
the
yeah.
values.
So if you have a set a parameter here, see it's like a variable, okay? It's like a variable. So these are the variable and values. Variable values, variable values, variable values. So these are the variable. Where to use it? Then you will open up a deployment.yaml and then you see stupid lines here. Okay, if you know someone, if you have understanding on the Python Zynga template or something, you will understand a little bit faster. Templating concept, you understand templating concept. In Zynga we have, in Python we have Zynga, Go we have a template, a PHP we have a blade, like that. You know that,
Yeah.
right? It's a variable. Okay, so here you declare the values and variable, and here you're calling that variable. So let me see that where is been called image.repository. Let me search for it. And I don't think so. I should tell you what is this line means. Image. Remember this YAML file for the pod. Let me show you that actually. If you're not able to correlate, see deployment, kind deployment, spec, template, spec containers, image. So spec container image, spec containers image. This is the variable for value. This is how you write it. I'll teach you. I mean, everything will practice a little bit, but here it is image dot repository. So here what we have, image dot repository. So this is the what image name. This is the tag. If you understand the tag, so this is the tag is will be empty. So here will be empty as well. Tag will be empty. No problem. Are you understanding what is a values.yaml? So anything you want to change in the YAML file, I mean deployment file of YAML of Helm, you specify here and it will be easy. Default value will be picked up from here. Are you understanding, all of you? Hello?
Yeah. Yeah,
Yes,
Rajesh.
Rajesh.
So now you got a clarity what it contains also. So this is another image. Uh, this is another image for same visualizations. So more or less, I assume you understand that. So I can move ahead. Now, I have already answered, given how it will look like when you're not using Helm and with the Helm. So if you see that here, without Helm, you have a multiple YAML files, and the same YAML files you modify, hard code that all these values, hard code this. Remember, you hard code in YAML concept. There is no values concept actually, values.yaml concept. So you hard code everything, and it's very difficult to deploy in the production. Again, you have to change in the staging. Again, you have to change in the development environment. So it's like so much of confusion. So many YAML files, so many deployment commands, so many values propositions and all. But here, what you can do, you can keep it the separate values.yaml file for that same chart and deploy One value is for the production, one values.yaml for staging, one values.yaml for development, something like this. Let me tell you. So here you have one YAML file, right? So the values.yaml is a default, okay? But after that, what you can do, you can develop one values for custom hyphen values hyphen prod. See, and now only one chart. And if you want to overwrite this one, this is a default automatically take. But what about if you want to use it? So while installing it, -f and give this file name and done. Simple. Understanding? Hello?
Yeah, Rajesh.
Simple. So now using the same chart, you don't have to hard code anywhere and deploy. This is one of the advantage you have with Helm. So more or less you understood this. Now let's get comfortable with Helm terminology. So guys, when you use the Helm, multiple terminologies will be used. And with the discussion, we got to know what is chart at least. Okay. So chart is nothing but is a directory structure which contains multiple YAML file of the resources which you want to deploy in the Kubernetes. Simple. From where you download the chart, where can you store the chart, can you share the chart? So we have a repository, multiple repository. We have hundreds of repository we have. So that is the place. You can create your own repository. Now guys, understand that very simple thing. When you deploy a chart, please remember that when you deploy a chart, like say Helm install MySQL, then you have to associate one name to that installation, because you may deploy, please understand that you may deploy same chart 5 times in the same cluster. You may do that. So how can we differentiate which installation is first one and second one and third one and fourth one? How do you do that? 5 times you want to deploy same chart in the same cluster. How do you differentiate? So actually you can name this. You can name while installing it, saying that, hey, this is for my X application, this MySQL for my Y applications, and this MySQL for Z applications. So you can name that, and that we call it a release. So please read it. An instance of Helm chart deployed to Kubernetes cluster, you should name it, and that's called release. There is a new release created each time a chart is installed. Mind it, there's a new release created. So every time you install it, one new name you give it. Default also will take it up, but you can also give it that name. Are you understanding, all of you?
And yeah, Rajesh, this is a mandatory step.
Yeah, mandatory. Else default will take it up. Some default name you have it.
So, so it's just like every chart gets
Name. That's
overwritten,
called
or
release. No, no, no. One name will be there. This is compulsory. When you deploy that, it is a compulsory. You have to give the name. But there is a default name. What happens sometime? You can pass some XYZ and or some random name, and that will take it up. So like that. So while installing it itself, you'll have to give the name. It's a
okay.
mandatory. But others, how you will come to know which MySQL belong to your product or your installations? You have to give name, right?
Mm-hmm. Mm-hmm. Mm-hmm.
Because you can install multiple MySQL pod n number of times, right?
Mm-hmm. Correct. Correct.
So I'll put it in this way. This release you can consider as like a deployment. kubectl get deploy, if you remember, something like that.
Mm-hmm. But with a name.
Yeah. Values.yaml. I think you have understood values.yaml. So values are parameters that can be customized when installing a Helm chart. I explained it to you already. They allow you to configure the deployment by providing specific values for the variable defined in the chart. So remember, by default, you set variable in the values in the values.yaml. that is parameterized in the your chart YAML file, and then that's being used. Template directory structure, you know that very well. Templates are files written in Go template language that define Kubernetes resources manifest. So here, if you remember that I explained, your templates is nothing but a YAML file. Okay, but actually you need to set the mindset a little bit. We are having this YAML file, that's true. If you're not templating it, then why you are using Helm? First of all, think about the reason. You want to templatize, so you are using Helm. So for that, we call it templates. And this will automatically transform based on the values.yaml. That means it will change. The values will change. So that's the reason we call it templates. If you understand in a simple way, okay, if you understand in simple way, okay, template means what? I don't know how many of you are from the coding background, but there is a one page which is written profile.py. This code is running in your software. Now, guys, tell me one thing. How many accounts we have in the Facebook? Let's say 1 crore. It will be more than that, but 1 crore. Think about it. Simple concept. Are you going to create, programmer is going to create 1 crore profile.py, one for each user? No. What they do? They create one template. In Python, we call it Jinga2. Jinga, Jinja, Jinga2. Template. So what happens? They take the input from the database, each user, transform this file, and if you log in, you will see, I will log in, I will see Rajesh, and here Jamie will log in and he will see Jamie. So Jinga2 is taking that input from the DB and templatize and generate randomly those pages. This is the concept. It's not new concept I'm teaching you. It's there from ages. Every language we have a template. For example, if you see PHP template, I will just type in this one, it'll be easy. Template, and you see here, blade is being used. See here. Oh, just a second, hold on. This is PHP Laravel template. Just a second, Laravel template. So here we use blade for that. Okay. Every language we have a templating concept. See here, blade. Blade template. Now, different language, Python template. So here you have Jinga2. See here, Jinga2, Jinja2. Template in Golang. And here you have template again. So now I'm coming to just again, Go template. And you see here, regenerate. Hold on a second. Why it's not? It's coming. So here, this is the Golang. And look at this little bit carefully, this code. This is HTML code, okay? Nothing great about it. And now I'll stop it. See, this is the Golang. Now, why I'm showing you this one? So you understand the foundation. I mean, your mind should think, okay, everything is so simple. So this is a Go template. And if you look at this, are you able to correlate something? All of you. All of you.
Yes, yes, Rajesh.
What was that? What you correlated? Tell me, share with me. So why I'm calling it, this is a template means all these are template file. Okay, so now earlier I said, hey, this template directory, you have all the YAML, but now I'm changing my stand. I'm saying yes, it's YAML file only, but in a template format. This will be transformed based on the values.yaml automatically. So why I'm showing you Golang? I'm showing you Golang because Helm is developed using what? Helm is developed using
Go.
Go, and same way. So that is the reason we are using this Go template. So this is nothing but the Go template actually. You see that I showed you just now. You see, this is the index.html. They are doing through the Go, and here this is the Helm. They are templating it. So now you are understanding what is template directory means. Template directory means it is a template file for your deployment to the Kubernetes. It will transform based on the values.yaml. Are you understanding, right? All of you? Hello?
Yeah.
Yeah. Now next one is terminology release namespace. I discussed little bit of it. So release namespace is the Kubernetes namespace. Kubernetes namespace you understand, right? Yeah.
Yeah,
Kubernetes.
namespace is something that uh, we bifurcate resources for a particular application.
Okay, I will not try to
I mean,
correct
we
you right now.
deploy. Yeah.
But yes, we need to understand those, because you understand that it's a package tool for the Kubernetes. So you need to know. I'll give you at the end of it, means I'll give you 15 resources today, and that you need to do the stuff before tomorrow. So that way it will be easy for you to grasp this all this stuff. It's very easy though. But yeah. Okay, so release namespace. A release namespace is the Kubernetes namespace in which a release is deployed. I told you, right? Every installations you have to name with the release, and it can be default namespace, or you can create a new namespace altogether. Okay, so by default, Helm deploy release to the same namespace as the tiller. Now this concept, just ignore it because the tiller is not at all. Let me remove this because two is a two. Okay, so we are learning three. Okay, now dependencies. Dependencies. What is the dependencies? So guys, dependencies like one chart is dependent on other chart. Yes, there are two charts around. So web 1, web 2, MySQL 1 application, something like that. So there are two charts and one chart is dependent on other. That means, hey, I'm installing the MySQL. Before the MySQL, X chart should be deployed. Or hey, I'm installing the application chart. Before application chart, MySQL chart should be deployed. So how do we set the dependency? How do we set the dependency? A Helm dependency is a chart that another chart depends on, and it allows to manage complex deployment by specifying and resolving dependency between charts. So what I'm trying to say here, guys, tell me one file name which you did not understand so far. One file name. Hello? In this, tell me one file name which you do not understand.
Underscore helpers.tl, TPL.
That is, you can ignore right now. Ignore this. Any other?
Charts or YAML.
This one, right? So chart.yaml, we can call it a meta file for the chart. Meta file for the chart means what is the chart name? Who's the chart author? How to use it? Copyright statement, some more specifications, and plus dependency. So you there is one more chart you have, and if you want to set the dependency, this file should be used. I'll show you this file for time being. We'll complicate slowly little bit later. Okay, see here. What is the name? Description, type, version, app version. Now let's say you don't understand what is the application type. So here you have some detailing on this. Okay, so application charts are a collection of templates that can be packaged into version archive to be deployed. That when we start sharing it, you will understand that. But there's a two types of chart. One is application, one is library. So this application is YAML file, but library is like a kind of function which is written in Go with the help of Go and stuff like that. So I'll teach you that one also later point of the time. Okay, so that is something which you have it. Okay, so now that is the, and dependency lines will be here only, but right now it's not added because just a skeleton. Okay, and then upgrade, you know that you want to upgrade your chart. That's a conceptual thing. And you want to roll back also. That's a conceptual thing. I assume you have done this upgrade and roll back in the deployment. How many of you have done it? So like that. Okay, so yeah, we understand this more or less. So this
I
structure,
have a question regarding upgrade, Rajesh.
yeah,
While upgrade, see, in one chart, I can have multiple services. True.
yeah, yeah.
Upgrading a chart means just upgrading or a rollback to a newer version of chart, or I can upgrade a specific service in the chart as well.
No, no, no. It's not upgrading a chart means simple thing. You were deploying MySQL 5.6. Now you are deploying 5.7. Simple. Rollback means you had deployed 5.7. Now you want to go back to 5.6. And this properties you have in the deployment actually. See, this is the properties of deployment. Deployment have a five property. One is replication, one is controller, one is versioning, one is rollout, one is rollback. Any one of you have tried in this group all these five features of deployment?
Uh, no, my question was, Rajesh, that let's say I have two services. My application, let's say I have a Java application and a MySQL database that are there in chart. Okay.
Mhm.
Now I change the version of the MySQL only, and I upgrade my chart.
Yeah,
So whether
it's upgrade.
both the pods will be started again, or just
No,
the delta, or what
no,
will
no.
happen?
Latest one will be deployed. Last one will be terminated. That is a
uh,
concept of deployment.
the last one means the application pod will also be the application will also be terminated.
Yeah, whichever the image you are changing, those pods will be terminated. New change, new version of image will be deployed that you are looking for, whatever the versions.
No, I have not changed the version of application, just changed the version of MySQL.
Okay, let me go into the basics again. This is your pod.
Yes.
Okay, so this pod, this is the image will be deployed.
Yes.
Next day, what you did, you deployed another image. So this will be terminated. This image will be, this pod will be terminated, and the new pod will be added. So now your
Yes.
question is, what is application? Understand this. Application you are getting confused with application version versus image version. Actually, there is no application version concept as such. Basically, you deploy the image itself, multiple different version. Application version you can call it something like this is the V1, so you can call it a V1, but your image also will be V1 like this. So this you name it, right? Correct now?
Yes.
So both are in sync. So let's not confuse with that, because application is yours, this one. Whatever the version, you can call the same version of applications also. Got it? Yeah.
Okay.
Okay, so now we understood this chart more or less. I wanted to discuss, but you have already understood this. So I'll not repeat the same topic. Here, this is the chart from registry. This is a local registry, all stuff like that, and so on. So you have a Helm chart, which is a template, chart.yaml, values.yaml. This is the default variable for all the files which is in template. And you run this chart, want to deploy in the Kubernetes. See, chart developer have given you default value. You want to override this, you change this values.yaml and deploy to the cluster. So this is something. So here there is a two role. One is chart developer, those who develop a chart. One is a user who deploy the chart. So user will change the values.yaml and then deploy the chart. Are you understanding, all of you? Hello? Hello?
Yeah.
Yeah, yes, Rajesh.
Yeah. Now I think I've shown you already, so I'll not drag this topic. You know what it contains in values.yaml. You know what it contains in deployment.yaml. You know what it contains in service.yaml. And Helm install, Helm my app, Helm upgrade my app, Helm roll back my app, Helm package my app. So install you understand, upgrade you understand, roll back you understand. These are the three commands. And package means you want to create a package and share with others. You do that. So here you see deployment has created this pod. Okay. And service has created one service. And now it's a very simple one. Okay. It in real time, it will complicate a lot. So you want to run this node Mongo in 8080 port, two replicas, and the service type is node port. This is just for visualizations, more or less. Understood, all of you? Hello?
Yeah, yes, Rajesh.
Yeah.
And one question here. So these files are updated manually or by the Helm itself?
No, which file? This one?
Like
Someone
the
write, no?
service.
Here, this guy is writing, chart developers. This guy will write for you. Those who are a very
Okay.
professional in the product team, development team, they will write for you. One person will write for you, and then other person will just you become user. Just like I'll put it in this way. I'm a package install engineer of Microsoft. I will create MS Office package. You guys will do what? You will copy, download it, and install it. Millions of people install it. So like that, two roles are there: developer and user. Got
Okay,
it?
so while working, there are minimal chances that we need to change service.yml.
That I don't know, because it depends on your application requirement.
Okay.
Because you say in a development you are running, you run in a two pod. I'm just giving one example. Hundreds of
Mm-hmm.
parameters is there, but you testing we need 20 pod. In production you need 2000 pod. It can be different requirements, right?
Okay.
Yeah. So look at this flow, how it happened. This is a very good image, but you need to focus on it. Look at this here. This is the template YAML and taking input from the values.yaml. And after that, process this chart.yaml, which is referring also subchart, which I'll talk about later. And then here you can publish to Helm repository, which is the site name, by the way, Helm repository, which contains for artifact hub. Please
Hub.
remember that. It's like a Docker hub. So now we call it artifact hub. Okay. And then this chart, you can install it. Okay. And the moment you install it, these values will be overwritten and it'll become on release in the cluster like that. Okay. Again, I think I have explained it to you, so I'll just ignore it. These slides. Are you comfortable right now? This one. This left side is a traditional method. Right side is the Helm. Traditional method, we had a multiple YAML. And what you used to do? Create, apply, create, apply, create, apply. Right side.
Mm-hmm.
Got it? Spring Boot is your name of your Helm chart. Got it, no?
Rajesh, one question I might have missed it. When we create when we install a chart, right? Or when we do Helm create or something, right? Which is the very first file that is being called from within the chart?
So first file which is getting called chart.yaml.
Chart.yaml, and from there the flow starts, and each template YAMLs are being called from there only, right?
So
in reference to each other.
So name is mentioned in the chart.yaml. So name is been read, which chart you want to deploy, and then what is being done? Values.yaml is transforming these template files and creating
that
the one.
That is clear.
Okay. Yeah. Good.
But I was confused from where the flow starts. That is chart.yaml.
Chart.yaml. Because that has a name actually. Name is important. I'll show you this one more time. This name is important. This directory name is not important, but it has to be in sync. This name and this has to be sync. This one.
But then what file is getting executed? That is not mentioned under this.
Yeah. No, that's every file. Every files of template will be executing.
And the dependency of each other file will be defined here. Like
in the chart.yaml. Chart.yaml.
Like, is there any predefined order?
That is a question, and that I'll keep it in a hold actually, because I want to show you some demo and then get into the order part actually. There is a order actually, so I'll discuss this one. Okay, so now guys, there is a two types of chart we have. One is a single chart and there is a one umbrella chart. So for time being, you understand the single chart and umbrella chart, but in a detail, I'll discuss what is happening under that. There's one. Did you notice something which we have not explained so far? Let me undo the stuff. Did you observe something which we have not explained? Anyone?
Like service account?
No, service account, I'm not explaining you. Service account, I'm not. These all are Kubernetes resources.
Just okay.
So I'm expecting all of you should be knowing that one, because I don't want to. I can help you at the high level, but if I start teaching you Kubernetes, my topics will be deviated. This one. Did you notice the charts directory was there? Right now, let me show you.
Yeah.
So this is called umbrella chart, but conceptually I'm telling you just to remind you, but later on I'll tell you what exactly it contains. Okay, so please at a high level you understand and remember that. That's all you needed. Okay, so this is done, and finally I think we have explained it to you already, this file, so no need to repeat one more time. Correct now? Great. So guys, now what is chart? Why do we need it? Chart, I mean, sorry, what is Helm? Why do we need it? Helm architecture, how Helm works, what is chart, and what is the structure of charts, and what are the files and all this stuff, the significance of each, and Helm terminology. Are we clear on this or not?
If you would have any issues with our channel membership, you can drop an email to us at contact@devops.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.